So let's take a look at just one more example. We're not going to expand on this. Just as a reminder, or back to the past or back to the future, from when you took Fundies 2. You had worked with various data types, but in particular you had worked with heaps. Yes, and in there already you were applying some of these same constraints, these same principles that we're introducing today formally. You had already been implementing some of these things, such as making sure that some properties of the heap were always maintained, right? The height of the heap, that any child of a node was also a heap, that the properties propagated across the entire data structure. Yes, and that any operation on the heap always maintained this invariance. Yes, but we never formally called it invariance. So let's revisit this just a bit. Right. So basically, when you implemented heaps, it was with the intent of maintaining some type of some level of performance, right? That somehow the performance of doing various operations on a heap was somewhat proportional to the height of the heap. Yes, and all sorts of transformations every time you added elements to the heap or removed things from the heap. There were some operations that you had to do on the heap to maintain some of these class invariants. Yes, now we have a name for this. All the operations guaranteed that the heap was always was balanced, that the height was always the shortest path from the root to any one element, right? And all operations on the heap maintain these invariants. So back then, perhaps we might have talked about it in terms of maintaining a structural invariance, right? That that each heap, each node maintained a subheap, right, on other end, and those heaps always maintain the same property, but the structure was being maintained. Other types of invariants, like the logical that that all the subheaps, all the subtrees were also heaps, and then the height was always some. We're ensuring that it was always the shortest path from the root to the base of the heap, right? Both of these invariants are instantaneous properties, meaning at any moment in time you can always just stop and look at the structure of the heap and verify and validate that indeed these two invariants are true. Right? That the height is the shortest path from the root to the base, and that looking at any one subtree in the heap is also a heap. I said at any one moment, before and after any operation, this was true. And so today we're introducing this formally. It's perhaps a little bit different in that when you're implementing these heaps, perhaps it was not just one class, perhaps it was spread out over multiple classes. Yes. So the invariants, as we talk about it today, we're talking about a particular class as class invariants. Here we're going a little bit broader. We're not talking about the invariants of one particular class, but perhaps as a collection of classes, implementing a particular data type. Yes. That as a whole are responsible for maintaining these invariances, right? Obviously, with if you're talking that your particular data type is implemented in a single class, then class invariants and these structural or logical invariants are kind of the same thing, conceptually. But it's very unlikely that data types are as trivial as to just use one single class, right? More often, a particular data type might involve multiple classes. Yes, very much like your implementation of heaps, perhaps in Fundies 2. Right? So these terms and these concepts of logical invariance and structural invariance are fairly similar to what, or largely the same of what we're talking about here as class invariance. Yes. Again, you would have to first identify what those invariants are. Right? And then all the methods that operate on the data type make sure that they leave the data type in the same way they found it. Right? whether the height of the heap or whether substructures within the trees of the heap. Make sense? Right. So again, some look back on what you might have done, what you might remember from Fundies 2.